So first of all, thanks everybody for coming here. To attend my Web3 Access Protocol talk. So this is the talk that we also gave at EthCC, which we have invited a speaking session there. So first, a quick introduction of myself. I have been here in the Web3 space full-time since 2018. Before that, I was a software engineer at Facebook, Google, working on all types of distributed systems, infrastructure. So every time I was attracted by the future of the Web3, so I decided to become a full-time developer and also focus on the Ethereum ecosystem. For example, I have a couple of the EIPs, 4804, which is today's talk, and also a couple of EIPs. And also I have a bunch of the writings on EthStorage and also Ethereum Magician. Also, we received multiple grants from Ethereum Foundation, both mainly focused on the data availability research and also layer 2 technologies, for example, data availability sampling research, and also EthStorage itself, which is a research on proof of storage algorithms on layer 2 off-chain data on top of Ethereum smart contract. So first of all, what is Web3 Access Protocol? It's defined in ERC 4804, so you can take a look at the standard from the Ethereum EIP repo. And the full name is called Web3 URL to EVM whole message translation. It is also an internet assigned number authority registered URI. Which means that we basically own this Web3 / prefix. And also the target of this URL is able to random web objects that is hosted by a smart contract. So here is a quick scheme of Web3 URL. It's very similar to HTTP, so sometimes we call decentralized HTTP. It has an authority, where in the HTTP it's a domain or IP address. But in our case, it is a smart contract, so you can use its ENS name or the contract address 0x and 20 bytes of hex. And you can also specify the chain ID so that it is natively support multi-chain, and also provide additional information about how to call this contract regarding which method and what are the parameters and what are for example, what are the data going to be returned and how to run it. So with this one, we are able to now, using a similar HTTP style link, but we are able to access the smart contract content and be able to, for example, to verifiably to check what the content would like to display to the users. So you can check the EIP here, and we also have our front page, which is right now it has two versions. One version is HTTP version, definitely, and there's also a Web3 version, which I really should put there. So why we need this access protocol? So you may have heard of IPFS, you may have heard of like a bunch of other protocols, but why we need this native access protocol to random objects on smart contracts? So one thing that we observe is that more and more NFTs, they are now moving to be fully on-chain. For example, that here is a couple of the NFTs, Cyberblocker, Nonce, Moonbirds, and also like Unblocks, these Nonce. And so their narrative is like to be truly fully decentralized as an NFT. Not only the smart contract associated with the token ID should be owned by the users on the Ethereum layer 1, but also the corresponding metadata, the asset itself, should also be owned by the users. The users, the owner, have the right to first forever access this data, the same as the smart contract itself. Second, has the ownership to, for example, I may be able to want to delete the data or make some changes of this data based on the corresponding logic that is allowed by the NFT smart contract. So they spend, I believe, tens of thousands or even some hundreds of dollars to upload all this data, images, using different type of format. For example, this is bitmap, this is SVG with different multiple layers. Other blocks is using JavaScript to random. This is also on bitmap. So And then so, oh, this is really interesting application, especially I believe this is very important for NFT owners, because if they really care about the ownership of the data of the images, which they pay maybe 1 Ether or 10 Ether to buy an NFT. And so I take a closer look of these smart contracts. I was quite surprised that, because when I browse this URI of the token and tell where basically these images are being accessed, for example, by OpenSea or Blur, and it just return a centralized server, say, hey, all the metadata and the images is now hosted by these, perhaps AWS servers.
It's Google App Engine, yeah.
Sorry?
Google App Engine.
That's a kind of engine, run app engine.
The domain is.
Okay, yeah. And also, this is a 97 using IPFS. This said, hey, why do we need to rely on third-party trust? Even though the data is already available on top of Ethereum. Why not just build an access protocol to directly access this content without any third-party trust? And we can fully verify those content directly. And that is the original motivation of Web3 access protocol, which we want to basically inherit most features of HTTP. So thanks to HTTP, it provides so many rich features combined with HTML, so that now we are able to reuse all these main features, but at the same time, we just replace some small parts. For example, we just placed authority with a decentralized one. It can be a smart contract or address, and define a way to how to call the smart contract to, for example, display the images of the first token ID or second token ID or maybe 100. And so that's the motivation that we start to define Web3 URL and then to experiment all this on-chain data. And then this Web3 URL was submitted on February last year and was finalized this year after 1 year's all kinds of experiment, discussion, reviews with EIP editors. So another question is, now we have this standard. Still, there's a lot of extensions that need to be finalized, but now it's now be able to support a lot of interesting type of applications. How we are able to use this Web3 URL so that we are able to experiment all these features. So one way is to use the gateway. So with the gateway, we just replace basically the authority and put in the gateway subdomain, and then the rest of the field will be parsed according to the EIP 4804 to the corresponding core data, and the gateway will change this message and call the corresponding message to the Ethereum. And definitely this is kind of like we call Web 2.5 solution at the current stage, because we have to go through this transition. But at the same, and this is also the gateway that support a bunch of the links, a bunch of the chains. And at the same time, our community developers, they just voluntarily come, oh, this is really interesting idea. So how we are able to make it to be fully Web3. And so there's a anonymous developer, and he put a lot of effort, say, hey, he come up with an extension so that now you are able to type Web3 and you type the link, then it will automatically translate to the EVM Ether core messages, call the JSON RPC server, which is configurable, similar to MetaMask. And now it's able to access this content and display on the browser. So this is I would say very like a future of envision the future about how the Web3 native be able to use existing popular browsers to access this content. And also, there's another developer. Oh, this is actually the basically how it works. And actually, another developer, which is also a community developer, they just come up with its browser, actually its own browser, that is able to type this Web3 URL, so that now you can also browse all the content that we are available on top of blockchain. So there are a bunch of applications that can be enabled by Web3 Access Protocol. The initial application will definitely be NFT images, so that we are able to render those images natively. So for example, cyberblockers, they upload all the media data. That is they call SVG layers, and on chain, and so that they say, hey, people never be afraid of losing their data on chain. So in order to display those content, we deploy a contract, which is you can imagine this is kind of a render contract, will tell us how we are able to render this link, for example, random block with token ID. Then it will retrieve the corresponding on-chain data from the Cyberblock's smart contract, put them together, and then be able to display it using Web3 Access Protocol. So this is the very early experiment that we say how we are able to serve those MT projects. It's just very simple, straightforward, a simple contract that follow the standard and be able to do that. Another thing, now looks like with Web3 Access Protocol, we are now able to transfer EVM to a decentralized HTTP server, which means that basically we are kind of like be able to experiment all the Web2 applications that are building on centralized HTTP server into Web3. And then say, hey, why not we are doing some more fancy or more aggressive applications? So early this year, we download all the Vitalik's blog, which is, I believe, is about 40 megabytes. And then say, hey, let's try how we are able to help Vitalik to run his blog on top of Ethereum rather than his centralized server. So we upload all these things and upload to the Arbitrum Nova, because like it has its DAC with much lower upload cost. That's something that I will also highlight some problem that need to solve. But with this smart contract, now we are able to have Vitalik to have his blog long life on top of Ethereum layer 1, layer 2. And that is something that we can envision when the Web3 is become so popular. It becomes, and also the scalability problem has been addressed by all types of techniques. For example, ZK Snark, and also, for example, some idea that we are proposing. We are able to deploy a lot of new type of applications similar to Web2, but on top of Web3, with combination of a lot of native features that Web3 can, unique features that Web3 can offer. So for example, in the future, I would imagine Ethereum.org itself should be also hosted on top of Ethereum. Or maybe another extreme case, just like a wild thinking, is like for example, Tornado Cash created a concern the censorship attack. Like for example, the Tornado Cash code GitHub repo is now frozen, archived, because of this. The Department of Justice has censored this website, even though like people can still access it, but it's now not able to work on it. And with smart contract and also a lot of technology that we are building, we are able also to build basically GitHub on top of Ethereum. And so now we are able to develop Ethereum on top of Ethereum using all this technology that we are building. This may take years to be realized, but this is just some crazy ideas that with all these things that's possible. Now we are able to create a completely new domain to not just do this like calculations of these stacks, but also a lot of applications that now Web2 applications are now possible on top of Ethereum. So there are a lot of other applications that we are experimenting. For example, decentralized Blogger, decentralized Dropbox, decentralized email, all kinds of these applications. So it's still at the early stage, but it has demonstrated very, very vivid, I would say, ecosystem to demonstrate a lot of possibilities. I have described a couple of the advantages and motivation of doing Web3 IL, but there are also a lot of blocking issues, challenges that we are facing. One issue is the storage problem of EVM. So we know that EVM will replicate all the data to all the nodes. We right now have 5,000 nodes, which means it will be super, super expensive to store all this data, to replicate the data to all the nodes. A quick calculation is that right now the storage cost of 1 gigabyte will take about 10 million. And that is definitely affordable to be able to have this technology to be massively adopted. Right now, we are using a solution that uses Aperture Nova with its data availability committee, which offload some of the storage tasks to their centralized servers. But at the same time, we are building even advanced solutions that we are able to build a called storage rollup, which we will have a side event tonight with EthStorage and Celestia. So that now we are able to reduce this cost to 1 to the 1,000, and also be able to scale the Ethereum storage capacity to petabytes. And also thanks to Ethereum Foundation, we also receive a grant to support our work, research work on this direction. For EthStorage, basically, we say that Ethereum is moving towards its scalability roadmap. One big direction is computation, so how to be able to achieve much faster or more transactions per second. At the same time, say, hey, those NFT, those front end of this DeFi, all these applications require a large amount of the storage that have almost the same level of the Ethereum security or for example, liveness, censorship attack, all these things. So the goal is like whether we are able to improve the Ethereum storage capacity in terms of space using similar rollup ideas, and that's the initial idea of the EthStorage, so that we are able to build a storage rollup rather than the computation rollup, and achieve a bunch of goals in terms of lower fees and also higher capacity, and everything is using Ether, and also it just for anyone with very minimum storage capacity. Right now the design is 4 terabytes. It can be able to decentralizedly join the network, download the data, prove the storage over time, and then get a corresponding reward. So with combining with EthStorage and Ethereum virtual machine, we are basically be able to mimic the current Web3 infrastructure, which we will have the application server, we will have storage services. But from user perspective, it just submit a single, for example, transaction. I write a tweet, write an article, I write a comment to the centralized services, and the rest thing will be handled by all these centralized components. While at the same time, on the top of Ethereum, we are actually approaching the, I would say, world computer goal. So here is a quick comparison. I don't want to go through a lot of these details. The major difference is like, for example, current rollups becoming a node that hosted the rollup state. There's no such incentive to basically running for example, backup sequencer. In general, it will be the project side will host a couple of the backup sequencers or backup nodes, make sure that the liveness of the network. But with EthStorage, the goal is to be able to build this using Ether as incentivized payment token, and also our proof of storage algorithms. So we are able to have a large number of the replicas or nodes that host the corresponding the data, and the hosting can be also be proven using our snark algorithms, and then be verified on top of smart contract. So that we are expecting the large number of the physical replicas, which also solve a lot of actually existing problem that ROA is facing, for example, verified dilemma problem. Also, there one other question is, what is the difference with EthStorage versus existing decentralized storage system? The one major difference is EthStorage is building on top of Ethereum data availability technologies. So it's a public storage system, while Falcon RV, they use private channels to upload the data. And second is like EthStorage is designed for high-value dynamic data. At the same time, Falcon RV, they are designed for static files with very limited semantics. For example, RV, the users are not allowed to delete any data that is uploaded to their blockchain. And Filecoin, update of very small pieces of data will be very, very inefficient in Filecoin. So in storage, we are able to dramatically scale the storage, but offer key value store semantics with much, much richer semantics. Second is, lastly is EthStorage is highly integrated with Ethereum. So all the users, they just only using the wallet, has Ethereum in their wallets, and also from developer perspective, as long as they understand smart contract, and understand all the development stack like Truffle, Waffle, Solidity, they can easily use the EthStorage to perform all the applications, tasks that the user and the developer would like to do. We believe with like EthStorage, the storage ROA, we want to not only use Ethereum security, but at the same time, we can also reuse the Ethereum ecosystem or the users. And this is the key factor, we believe, for the basically massive adoption. So here is a couple of technologies that to enable all this. So for example, we have to make sure the data is successfully published to the layer 1, layer 2 network. And so here we are working on data availability technologies. We are helping the Ethereum Foundation to solve some dank sharding problems. And so we have a grant received from Ethereum Foundation. And for the EthStorage itself, it's basically to build a decentralized layer 2 storage network and be able to verify the storage on top of layer 1, and on top of our invented proof of storage algorithms. And also we have a grant from EF to support the research. And lastly, Web3 Access Protocol is, you can imagine the application layer for EthStorage and also Ethereum, so that now we are able to access all this data, both in terms of layer 1 smart contract and also layer 2 EthStorage, and display this content on top of the fully decentralized access protocol in browser or gateway. So in the future, we believe like Ethereum will drive most innovations. We believe that it will become the world supercomputer. Suppose we solve this scalability problem. And with all these solutions, we are able to allow everybody and in anywhere to use Ethereum and enjoy all the benefits that Ethereum offers. And at the same time, we are able to make the whole network even more decentralized. So we can basically migrate a lot of like Web 2.5 projects to fully Web 3, or a lot of existing Web 2 projects or can be also now be able to support it on top of Ethereum whole ecosystem. So here is our timeline. So our Web3 Access Protocol is already online, so feel free to go to the website and browse all kinds of features, deploy your contract, and now also support Ethereum testnet. Or we also have a testnet to experiment this. So if you need testnet token, feel free to reach out to me. And so the reason we run our testnet so that we can essentially have infinite token to experiment all these crazy ideas. And at the same time, we are now doing a lot of work with integration with EIP 4844. That is the Ethereum current version of DA or pre-version of DA. So there's a lot of changes. For example, they just finished their testnet on DevNet on 7 and 8, and there's a lot of changes on the APIs. And at the same time, we closely follow all these changes and provide and contribute to our libraries, for example, to be able to support EIP 4844 ecosystem, so that we can experiment all these advanced features in early stage. Also, we are building this layer 2 network with Snark Prover, which is also built on top of definitely EIP 4844 DevNet. And also, for example, native browser integration, thanks to our anonymous developers that created such significant work to support Web3 AL at Chrome. And also, we have a couple of the organic talk that, for example, Ether AdCon, Ether CC, DevCon, Ether Denver, that to tell what we are doing and how we are able to contribute to the whole Web3 ecosystem. In the future, definitely we would like to integrate it with the DAM sharding. That is the famous Ethereum DA solution, and also the bunch of other work that needs to be done. So thanks for attending today's talk. So I would like to happy to see if anyone has any questions, both in terms of application, technical, or any other. Yeah, this is one.
Yeah, I do. I wonder what are the implications of this, like Ethereum storage compared to, for example, IPFS. As like ex-co-founder of the NFT marketplace, I know how like unreliable IPFS nodes are. How usually it takes like 10 seconds to retrieve any NFT. It takes you usually get like broken images, and I wonder how essentially fast and reliable is if Ethereum storage is.
Yeah. So let me repeat the question. So it's regarding some service quality of Filecoin, right?
I wonder where is data stored, and how reliable is that, and how fast could you actually retrieve the data? Could you actually compete with like Cloudflare, CDN, and all this stuff in terms of speed?
Yeah, that's a great question. So first of all, so I think this is more related to retrieval market, how we are able to ensure that we are able to, for example, deliver this content to the users. Our retrieval market is a complete model is a little bit different from Filecoin. It's more Ethereum side perspective. So right now the Ethereum retrieval market is like Ethereum have a bunch of P2P nodes, about 5,000, and then there's no guarantee that everybody can obtain the Ethereum, for example, balance or any storage slots in, for example, some kind of latency. But at the same time, when I become a new node in the Ethereum network, all those nodes will voluntarily share the data, so that, for example, for me, like I frequently set up the nodes. It took about half days to become an Ethereum node. At the same time, there are a couple of services, for example, Ethereum, the most famous one, and Alchemy, and the list of the others. They provide these services of the Ether core to query all the network information, kind of a centralized way, but with much higher quality of service. And lastly, Ethereum is also building called Portal Network. You can imagine that is a decentralized Ethereum like JSON RPC network that store this data, but it doesn't guarantee any quality of services. For EthStorage, it's similar because it is a natural Ethereum layer 2, so that it's you can imagine this is a superset of Ethereum. So which means that we also have a bunch of nodes, storage nodes that run in the P2P network. It does not guarantee any latency of the data can be retrieved. That is the same issue as the basic order blockchain. And second is that we are projecting there's a similar market. It can be maybe inferior, something that we are basically working with, so that they can offer kind of a centralized but verifiable retrieval market. It may provide some rate limitings for free users, but at the same time, for example, suppose I'm a big project like Mirror XYZ completely is a storage providers for any traffic, or they can itself can be storage provider to set up their network. So there are a bunch of ways. The thing is like the replication factor of EthStorage will be much higher than Filecoin, because the Filecoin is kind of like a private storage market. So basically, when a Filecoin I want to store data, I find some storage providers and pay the corresponding contract. But very small amount of replica at the same time, which means that it would be harder for example, for inferior or some public services to find the storage provider and retrieve data, because in general they may not likely to pin the data on top of IPFS. So there are a couple of major difference there, and we don't want to reinvent view, just adopt the best practice of current Ethereum network has, both in terms of P2P network and also the retrieval market.
So it's essentially the same as layer 2 chain, but it's exactly designed for storing the data, right? And it's obviously like supports rollups with Ethereum.
Yeah, but actually it does not have a chain. It does not have a chain. So it is a modular storage.
So you fully rely on the existing Ethereum infrastructure to store the data?
Yeah, you use Ethereum ledger to store the data. So the ledger just store the. So you can imagine the Ethereum ledger using IPFS is just store the content hash. In our case, the Ethereum ledger, let's using just L1 as an example, it just contains the commitment. But unlike IPFS, nobody can tell that the data can be retrieved or not on top of Ethereum. We will tell periodically that, hey, for this data corresponding to the commitment, there is a oracle.
Immutable.
Yeah, that's not compressed proof, tells that the data that are actually stored by a large number of nodes. And this is a proof. And this is really, really different. I would say much higher in terms of liveness and work for the data built on top of Ethereum. Yeah.
Thank you.
Yeah, next question. Probably can start with yeah.
It's okay. Thank you. I have two questions actually, but I can start from one. So
Sure.
we are building a layer 1. And our CTO mentioned to me about EthStorage before, because we are looking for a solution for the storage. But I think that from you speaking, I can say you mostly you support is Ethereum ecosystem, Ethereum layer 1 or layer 2. So, but we are an EVM chain, but building on top of Tendermint in Cosmos ecosystem. So we just wonder, will you support other EVM chain besides Ethereum ecosystem? And also, sorry,
Yeah, no worries. So you can ask me later if once you come to the question. Yeah, so right now the Web3 access protocol is support multiple blockchains. Actually, it will be very easy to support additional blockchain as long as the blockchain follows Ethereum JSON RPC standard. So to allow EthStorage to support another layer 1, the one major thing is to solve the proof of publication problem, because we want everything to be public, which means that the data we're using core data model will be super slow. So you can imagine like the core data or basically EIP data availability is a scalable version of block space. And EthStorage is a scalable version of the world state of Ethereum. But this is a dependency. So otherwise, user may save 1 to the 1,000 of the storage cost, but the upload cost is still the same. So that the major cost is still be blocked by the upload cost. That's why we are working with a couple of the DAs to help to solve this problem, besides the Ethereum DA.
Makes sense. I'm kind of curious because like we want to maybe have our midnight launch next year or public night launch at the beginning of next year. So is that because I see you roadmap, you plan to launch your dev night this year and test night next year, and midnight 2 years later. So we wonder if it's still available to use it even for our next year test night and midnight.
So our roadmap is a little bit faster because like we do not need to wait until the dank sharding to be ready to launch the network. it just need to be wait for the EIP 4844, and so that we are primary tested on EIP 4844. That is the current, they call it forward compatible version of Dankshotting. And with the this feature, once that is fully tested, then we can definitely, because it's modular, then we can easily plug in into any other EVM network as long as there's a DA solution. Or worst case can also using core data, but probably the gas saving will not be so significant. Yeah. Yeah. Sorry.
这个有那种挖矿机制吗？
哦，
有，
就是挖矿 mining 是吧？
挖矿对 mining 像 Filecoin 啊这些。
So let me repeat the question. Is there any mining mechanism of the whole system? There's a mining, but we call it proving.
Yeah.
So basically, when I'm a storage provider, I store a copy of the data, and then I can prove I store this data over time. Then our system is going to reward anyone with the corresponding storage fee, which is the 1 over M, where M is the total number of a physical replica in the network. We call fee distributor. But this proving process is actually the same as the mining process, but we do not need an independent blockchain to complete this mining process, because like all this verification logic, we can be done in Ethereum smart contract, and a lot of like a complicated computation can be done using Snark too. So that's why we do not need to set a new chain and do a lot of new things like precompiles or new features to support this mining process. Yeah, it is some kind of mining, but the main goal is to able to fairly distribute the fee to the storage provider, so that everyone is expected to receive 1 over M storage fee over this time, where M is number of replicas. Yeah. Yeah.
Hi, Doctor. Quick question on the programmable data.
Yes.
Could you give some use case scenarios for programmable data storage on chain? Because I feel like the very obvious difference is that they are not programmable, right?
Yeah, exactly.
That's my first question. The second one is what's the flexibility you think for privacy preserving on-chain data storage? Because that's just what we are very interested in looking at.
Nice. So first thing regarding programmability, there are actually, I will say there are some two difference. You can imagine the impacts of programmability. So first of all, the Filecoin case, when I give a link of Filecoin, it is always static. Either I can show images that never changes, or either I cannot open the file. This is the IPFS case. In the programmable storage cases, because the smart contract will have the logic to organize the data, where to put it, how the user open it, all this. So every time when I call the contract with the same link, it's able to dynamically return the content that the application logic and storage logic that they would like to return. So for example, each time when I read Elon Musk tweets, the first time I read and tomorrow I read will be different, because the application will say, oh, Elon Musk has new tweets, has new article or new comments, and that will dynamically return the content back to the front end. And that is the problem that we want to solve, and that is the major difference of Web 1.0 and Web 2.0, because 1.0 is everything static. Probably everybody maintain their website using FTP, upload these things. But now we have Web 2.0. Everybody just using browser, interact with the servers with some link that can dynamically render this content. And this is the first why this programmability dynamic content is very important. And second is it can also control this data ownership. So for example, I upload some data on top of this, for example, Ethereum token EthStorage, and I would like to, for example, to update this data. For example, I can update these tweets, and the basically who is able to update these tweets, the logic, the ownership logic is managed by the smart contract. So the smart contract can say, oh, I'm the owner now. I can do this this kind of task. I can modify, or even I can delete other comments, or this, or I'm not authorized to do so. So I don't have the right to, for example, remove the data from the smart contract. So that is the power of, we are able to combine the EVM, that's programmability, and also the storage together, and that is able to enable all types of applications that Web2 can support. Especially, there's a very interesting story that when Google launched Gmail on April the 1st, people was saying, oh, Google is making a joke to offer gigabytes of email system. But later, everybody found, oh, this is reality. They really did it. And people are surprised how they do that. And actually, on their backbone, they develop a very large-scale key-value store called Bigtable, with their also very scalable application logic, put them together so that they are able to store a large amount of data using a distributed system, horizontal. It can easily horizontally scale, and then offer gigabytes of the spaces to the users. And that is the magic that Google, Facebook has been done in 20 years ago. But now we want to repeat this magic in the Web3 world. And that is according to my previous experience, and inspire me why we need this kind of infrastructure in Web3.
Oh, and the second one, privacy preserving.
Sure.
Privacy preserving.
Oh, but yeah, privacy preserving. That's a good question. So one thing is like we are dealing with the public storage market. So it's similar to the blockchain ledger itself. So for the privacy, right now we don't offer any protocol level support on privacy, but at the same time, we already have some demo applications you can try. For example, there's email, so that I can using the destination public key and encrypt using the public key, so that we only allow the sender and also recipient to be able to decode a message that carry using the EthStorage. And that's one way to solve this end-to-end privacy problem. There's also called a private drive, which is basically I can upload data, and it will basically using the user's private key to generate encryption key, because for example, MetaMask's signing logic will generate deterministic signature. Even though ECTS allows like randomized signature, and so with that, it's able to using that as the encryption key to encode data, for anyone as long as the private key will also be decrypted data, and then to show, oh, this is the, for example, some legal documents I want to store forever, but at the same time I don't want everybody can read it.
Yeah. So that's like a private vault in this storage, right?
Yeah, there's a demo there, even though it's still using on-chain data on the testnet, but that is how the EthStorage will work together with the EIP for upgrade.
Gotcha, thank you.
I'll get back to my question. So it's start from an application side one. So because I was expecting you can provide storage for Ethereum, definitely, but you also mentioned that you can even provide security, even users of Ethereum. So kind of curious. Maybe
Okay.
I heard it wrong, but I don't know.
Yeah, I think so. One thing is like we want to reuse Ethereum security. But at the same time, which I would say more precisely word is to maximize the security with Ethereum. But like because the storage provider network is a little bit different with validated network, so that the security level will be a little bit different. But thing is like everything, for example, proof of storage is verified on top of Ethereum. The data passing through will also go through Ethereum from DA, so that we want to maximize the security from Ethereum. But actually, Ethereum right now, its state or its storage security is also an open question. because like from Vitalik saying is that as long as there's one node that stores the Ethereum full node, then the Ethereum state is secure. There is 1/1. They call 100% security versus like 51% or 66.7%. But how we are able to define precisely this security is a little bit tricky. But things like it's 1%, so that it's compared to like other like higher security assumptions that it will be much easier to achieve.
Great, thank you. In your comparison, you just mentioned there is on-chain programmability, programmable. So what does this mean? Because you mentioned Filecoin and Array don't have this kind of on-chain programmability. So just curious about what the on-chain programmability mean here.
So on-chain programmability means that we are able to, so using the smart contract to be able to manipulate because it's key value store, right? So the key can be from application, what the key looks like, and the value is how the value associated with the key, how to change this value, who is able to change the value, is programmed by smart contract. Yeah.
It's always different than my imagination. I was imagining that users can build smart contract on top of it, and then maybe there is a VM on top of EthStorage, but it's different, right? It's like value can be changed, right?
So from read part, there is a emulated VM that is able to also read the data, and in VM level to manipulate. But that is only for read-only purposes.
Yeah.
Like demonstrating the website, read the tweets, so we are able to have one Ether code to be able to return the whole website. Where part of the data is from EthStorage.
Great.
Yeah. Because like we are not able to modify EVM by itself in the transaction. Yeah.
Thanks. I don't have any other questions. Thank you.
Do you have a question?
No.
Oh, okay. So thanks for sharing.
Right.
Let's move to the next talk.